Isotopes are different forms of the same atom which have the same number of protons, but they have different number of neutrons. This means that isotopes will have the same atomic number, but they're going to have different mass number. A typical example of isotopes are carbon 12 and carbon 13. So both carbons have the same atomic number, which is 6 because they have the same number of protons, but they have a different number of neutrons, so they have different mass number, which is 12 for carbon 12 and 13 for carbon 13. For carbon 12, the number of protons and electrons both are the same, which is 6, and the number of neutrons is 6. For carbon 13, number of protons and electrons still the same, which is 6 because it's the same atom, which is carbon, but the number of proton here has changed and it's 7. Relative atomic mass. The relative atomic mass is the average mass of a certain atom, taking into account the different masses and abundances of all isotopes that make up the element. So in the periodic table, the mass that you're going to find for the different elements is actually the relative atomic mass, not the atomic mass, the relative atomic mass, not the mass number or the mass of a particular isotope. So it takes into account all the different isotope of the element. Many elements exist as a number of different isotopes, and the relative atomic mass is used and reported in the periodic table instead of the mass when the atomic mass when we are referring to a specific atom. We have a certain equation that we use to calculate the relative atomic mass. So if we have two different isotopes, isotope A and B of the same element, each of these have a certain abundance or percentage, and then we can calculate the relative atomic mass if we multiply the relative abundance of isotope A by the mass of isotope A, and we add this to the relative abundance of isotope B times the mass of isotope B, and we divide this by 100, or we divide it by the total abundance of all the isotopes. So let's have an example of calculation of relative atomic mass using this equation. Now we have chlorine, one of the elements in the periodic table. There are two masses, or there are two isotopes of chlorine. Chlorine 35, which has the atomic mass of 35, and we have chlorine 37. The relative abundance of chlorine 35 is 3, and the relative abundance of chlorine 37 is 1. Now, to calculate the relative atomic mass, we multiply the atomic mass of the first isotope times the abundance of this one, which is 35 times 3, and then we add this to the multiplication of the mass of the second isotope times its abundance, which is 1, over the total abundance of all the isotopes, which is 4, and then you're going to find that the relative atomic mass of chlorine is 35.5. If you look at the periodic table, you're going to find that chlorine has a mass of 35.5 because this is the relative atomic mass of all the isotopes.